limits with trigonometric functions. In this video, we will practice the property as x is approaching 0, sine of x over x, and we will see this property in some of the trigonometric functions, and we will try to compute that limit. Let's see. We will just practice in this video. Okay, that means that's all of the limits. We know that this is true. We had the proof of this property. Of course, this is the main property, if I can say this way, sine of x over x. As x is approaches 0, this limit is 1. And then algebraically, reciprocal is also 1, and algebraically and respecting the limits laws. This is 1. Tangent of x over x, since tangent is sine of x over cosine of x, cosine of x as x approaches 0 is 1, then this is almost the same. And of course, the reciprocal. Okay, we know these limits, we discussed. Let's practice. Example number 1. Limit as x approaches 0, sine of 2x over x. We may notice that is sine of 0 over 0, which is indeterminate form, because sine of 0 is 0, 0 over 0. So let's see. We do see sine of 2x. Sine of 2x. Then it would be nice to have also 2x in the denominator, because then we know that this property is 1 if we have sine of 2x over identical quantity 2x. Then I multiply denominator, I will also multiply numerator to keep the original fraction the same. And that property, of course, is 1. 2 times 1, the limit is 2. Okay, but we can see the blue box is the property. Okay, another one. X approaches 0, x times cosine of 4x over sine of 8x. Again, x is 0, cosine at 0 is 1, sine at 0 is 0. We do have indeterminate form 0 over 0. Okay, let's use the property because we may see this. I have x, cosine of 4x, and then sine of 8x. Again, we're missing the coefficient 8 of x. That means I will multiply and divide the numerator and denominator. And this is my property. 8x over sine of 8x, the same 0. Yeah, we can see the same identical 0. This limit is 1. And then cosine 4 times 0 is 0. Cosine at 0 is 1. Okay, 1 times 1, 1 over 8, 1/8. Okay, another one. Sine of x minus 1 over x squared plus x minus 2 as x approaches 1. And we have to figure out the behavior of this function at 1. Sine 1 minus 1, 0. Sine at 0, 0. 1 squared plus 1 minus 2 is also 0. Of course, we are not surprised. Indeterminate form 0 over 0. And what we see, we have sine of x minus 1. When we factor out denominator, let's see, I think it's this. We may notice the same quantity, sine of x over x minus 1 over x minus 1. And x minus 1 is 0 as x approaches 1. Sine of 0 over 0, this is 1. Okay, I can maybe put one more step. We simplify this to 1 and we end up with x plus 2. X is 1, 1 plus 2, 3, 1/3. Example number 4. 4. Okay. Let's maybe speed up a little bit. We have sine of 4x over 3x. We will definitely need 4. I am multiplying and dividing. And this sine of 4x over 4x, this is 1. What's left is 4 over 3. Okay, this one, example number 5, of course, it was 0 over 0. This is also 0 over 0. We can see sine of 2x cubed and x cubed in the denominator. Since the power is the same, I may use the property and put like this. Limit of the power function is power of that limit. This means I can compute the limit of the inner function, since power function cube is continuous function, sine of 2x over x, and everything will be cubed. And we know that this limit is 2, but let's make sure we're multiplying by 2. We have to know where the 2 come from. And this property, sine of 2x over identical number, this is 1. And we will end up with 1 cube and 2 cube. 1 cube, of course, is 1. The limit is 8. Okay, and similarly, we may see x and sine of 4x, everything squared. Yeah? Of course, indeterminate form. Limit Sx, and we may square the entire limit. This limit, of course, x goes to 0, and this limit is, let's multiply everything, numerator and denominator, by 4, because we need that 4 to use the property. 4x over sine of 4x is 1. 1/4 stays inside. Squared 1 over 16. Okay. Oh, too fast. Example number 7. Limit as x goes to 0, sine of x over tan 7x. Tangent is also hold this property because behind tangent we know that we have sine. Okay, that means this tangent at 0, sine at 0 is 0, 0 over 0. So what we can do, I will put sine and I will do something like this. And I will need, in order to use the property, I will multiply and divide by x. Okay? And I will multiply and divide by 7x. Probably I double the x, but I will cancel out because this property is 1 and this property is 1. And what's left, I can rewrite this x over 7x, which we can cancel out 1/7. Yeah? We may skip the x right away, but I think that's a good way to solve it. Okay, let's do the next one. Sine of 0 over 0, 0 over 0, x approaches 0. We have sine of x squared. Sine of x squared, that's mean, and we only have 1x. That's what we will do. I will multiply and divide by x. We know that x is not exactly 0. It's a small number, arbitrary small, and near to 0. That means I'm allowed to multiply and divide. Okay, and what I will do, I will rewrite this and this because that's my property. And we will, oh, actually, I wanted, let's be consistent. Okay, x approaches 0. Blue color for the property, sine of x squared over x squared. That's the same angle, that, and it's 0, that limit is 1. And then we end up with x. Just x approaches 0x. We did eliminate 0 from the denominator. That's when we find x. If x is 0, limit of x approaches 0, limit at 0 is 0. I mean, yeah, we did get 0, but we do have a strong reason for this. Okay. Okay, example number 9. x approaches 0, x times cotangent of x. We may check x is 0, and cotangent at 0, if we remember, is undefined. Yes, cotangent function has a vertical asymptote because cotangent is cosine over sine, sine is 0, we're not dividing by 0. Okay, that definitely is indeterminate form, 0 times infinity, positive, negative, we don't, but 0 times something undefined is indeterminate form. Let's rewrite. We may remember that we like to see a product, the indeterminate product form, in the form of the quotient, because we feel more confident analyzing, computing the quotient. That means it's easy because I can just put cosine of x over sine of x. And actually that's even better because that's the property, x over sine of x. X over sine of x is 1, and then we will end up with function cosine, and cosine at 0, of course, everybody knows the unit circle, it's 1, okay? Another page. Oh, okay. Example 10, 11, and 12. Example 10, you probably know the answer, but we have to be always careful, not always take the ratio of the coefficient. I will just write this for you because we have to have the reason. I know that we like the shortcuts, but I will put 8x and 8x. I will put 5x and 5x, okay, as a product. And now this is 1 and this is 1. Okay, 8x over 5x is 8 over 5. Okay, now example number 11 and 12 are slightly different because we have expanded form, addition. Okay, but since we're practicing this property, we may think, okay, I have to force it to use that property. Of course, 0 over 0. All of the examples are in this form. Okay, I will multiply each term by 1 over x, numerator and denominator, each term. And let's see what we will get. Sine of x over x, and then x over x, and then tan x over x. Nice. And this limit is 1, this is just 1, and this limit is 1/2. Okay, and we will do the same thing here. I will multiply still by 1 over x. We have to adjust the coefficients, but let's see first. Sine of 3x over x, 4x over x, and tan 2x over x. We know from the example number 1, this limit will be 3. This will be cancelled out to 4. And tan of 2x over x, this limit will be 2. Okay, 3 over 6, it's actually 1/2. Okay, that's the nice trick. Another page. Oh, now, okay, 13. Limit as x approaches 0, cosine of x minus 1 over sine of x. Cosine at 0 is 1. 1 minus 1 is 0. Sine at 0 is 0. 0. 0 over 0. And what we can do here, we may try the same thing, like multiply everything by 1 over x. But I am afraid that cosine of x over x will be not helpful. 1 over x will be also not helpful. We will create like another indeterminate forms inside this indeterminate form. Okay? And you may remember that when we see a limit with indeterminate form, limit of the function, that includes the root expressions, we practice square root expressions, we may use the approach of multiplying by conjugate. And for the square root expressions, and actually for some trigonometric expressions, it will work. And that means let's multiply by the conjugate expression cosine of x plus 1. Multiply and divide. Because we have cosine of x minus 1. When we distribute this multiplication, of course, I'm using a minus b, a plus b, a squared minus b squared. Okay, it means cosine squared minus 1 squared, which is 1. And then I can copy sine of x. We will not distribute denominator because sine of x is 0, and we need that. If I will distribute, I will spread out that 0. We may notice in the numerator, cosine squared minus 1 is sine square of x. Okay, cosine of x plus 1, another step. Sine square of x is sine of x times sine of x. Actually, I could cancel out, but it's fine. And we may cancel out that 0. We're not really using the property, I might realize. We never know because it is 0 over 0. Sine of x is sitting here, but it looks like we will not use this because we just got a finite number, sine of 0, cosine of 0, and we may use, that's what I did, just direct substitution. This is 0, 1 plus 1, 0 over 2, of course, is 0. This is fine. This is finite number. We did eliminate 0 from the denominator. Okay. Let's recap the of course, important message on this slide, on this example, is the green step, multiplying by the conjugate. Yeah, remember about this, especially when we have like minus plus 1, 1. Yeah, and we may think, and we like squared trigonometric functions because the ratios, trigonometric identities are based on the right triangle, and the right triangle, Pythagorean theorem, we like the squares. Okay, I think I have 1 or 2 more problems, and this will be end of the practice video. Oh, too fast. Okay, I have this one. Square root 1 plus tangent x minus square root 1 plus sine of x over x cubed. Tangent and sine at 0 is 0. Square root of 1 minus square root of 1, of course, 1 minus 1, 0. Indeterminate form, 0 over 0. Yeah, and this one probably so easy to figure out the first step, conjugate expression. I'm multiplying and dividing. Yeah, let's say this is the product. Let's see. We will, again, I use a squared minus b squared because this is a, this is b. That means I squared the first quantity, the square root is gone. And I squared the second quantity, the square root is gone. And I did distribute negative, if you notice, minus 1 minus sine. And x is approaching 0. We assuming that this this expression is positive. Okay. And what I have, we definitely can cancel out this sine of x over cosine of x. I will rewrite the tangent. And when we get the common denominator here, we will get, oh, actually, I factor out sine of x. It's still fine. Because if the common denominator, we will drop the cosine down. But when I actually, because I see sine of x and sine of x, I factor out because I can at least eliminate one of the x. Sine of x over one of those x will be 1. Okay, that means let's see. Okay, I do have a common denominator here. Let me put, now I can, since this is product, but yeah, I have the property in a minute, I can drop down that cosine to the denominator. Okay, and I split the cube for squared and the single one, and this is the property. I mean, at least I eliminate one of the zero because we have x cubed. X times x times x, 0 times 0 times 0. We have 3 zeros. We have to get rid of all of them to get the answer. If we can't, probably will be undefined, but let's see. Okay, so this is another step that because we still have 0 over 0. I will multiply again by the conjugate of this, 1 minus cosine of x, 1 plus cosine, 1 plus cosine. And let's see. Actually, I copy this step on the other slide. And when I keep a product in the denominator, I just copy everything. 1 minus cosine times 1 plus cosine will be 1 squared minus cosine squared. And 1 minus cosine squared, we know what it is. This is basically sine squared. And I type this, but this and this will give us 1. This and this will give us 1. Actually, I nicely moved everything. I mean, this is 1, this is 1. And then now looks like we can substitute cosine at 0, tangent at 0, sine at 0, cosine at 0. Tangent and sine is 0. Square root of 1 plus square root of 1 will be 2, 1/2. Cosine at 0 is 1. 1 plus 1, 2. That's we will have 2 times 2, 4 times 1. 1, 4. Quite nice limit. And yes, we did use the property. We did use the property. Do I have one more? Oh, I have it, but it's similar. Yes, we just did similar, but let's do it. Let's finalize. Oh, we did identical. Let me check something. No, that was sine. Okay, that's me. Let's finalize our session with this example number 15. We definitely have 0 over 0. I am multiplying by the conjugate and dividing by the conjugate, 1 plus cosine. Let's see what we will get. Oh, actually, not x, theta. Theta goes to 0. We will keep a product because I need that theta. 1 minus cosine theta, 1 plus cosine theta is 1 squared minus cosine squared theta. 1 minus cosine squared theta is sine squared theta. We can see we may eliminate 1. We can eliminate actually 0 from the denominator because sine squared is sine theta times another sine and 1 plus cosine theta. Okay, and sine of theta over theta, as theta goes to 0, this limit is 1. And we will end up similarly to the example number 13, sine of 0, cosine of 0. Sine of 0 is 0. The answer is 0, but we definitely have finite number, non-zero finite number in the denominator. And we eliminate that 0. The answer is 0. Okay? You may redo all of the 15 problems and gain your confidence with this type of limit. Thank you.